Hi friends, welcome back. So we are working on synchronous sequential circuits. Then we have seen some basics about memory. We were implementing synchronous sequential circuits from the scratch. We started working with the gate version. Then when the things were very complicated, we started using the higher version like multiplexers and decoders. We are not happy with that. Then we started working with programmable logic devices like PLA and PALs. Now want to make it more concrete so that things can be implemented even at a higher complexity. So in this direction, I would like to make use of the memory just discussed in our previous session. Can memory be useful to us? Okay, let us see where we can use. So this was a state table we had defined for one two input two output case in our previous session. So I'm just copied this table for our further argument. So in this case, what are required is I want to know in what state our machine is. That means A and B are required. I want to know what are the inputs given which drive our system. So x1 and x2. So if I know A, B, x1, x2, then I can know then I can know what should be the outputs and what should be the driving forces for the two flip-flops A and B. So that means if I know this as my address and these four columns as my data, then yes, I can uh, use memory here. So what are the memory? I have a memory, and this memory has two address lines coming from our current state and two address lines coming from our two inputs, and this is going to give us 16. These four inputs are going to give us 16 combinations. So these 16 combinations are put inside. So this whole table is somehow stored inside. That means I just store for 0000, TA should be 0, TB should be 0. So that means I need one output as TA and one output as TB and one output Y1 and one output Y2. That's all I need. So this TA goes to a flip flop A, T input, and this goes to flip flop B as T input, and this output is fed back here. Done. So these two are provided with the clock, and these two are the outputs. So these two are inputs, these two are outputs. So when you begin the experiment, then assume that A, B, x1, x0 are 000. You are here. In that case, TA will be 1, TB will be 1, and y1 will be 0, y2 will be 0. So TA is 1, TB is 1. So 1 here will make this next state as 1. This will be made next state 1. So that's what we wanted here. So next state are going to be 1, 1. So next time 1, 1 are given here. So next time we are in this situation when A and B are 1, 1. Now depending on the input, depending on input If input is now 0 1, then the TA will be 1, TB will be 0, so this will be 1. So output was 1, now again toggles, so it becomes 0. This is 0, output was 1, will remain 1, so it will be 0 1. That's what you wanted. We wanted to go to 0 1, and the output generated will be 1 0. So that way, a simple circuit like this can now solve the problem. The advantage of this is, instead of having two inputs, if there are having three inputs, then yes, you can give three inputs to this. The only thing is, you are going to have, instead of what will be this table now, this table will have 16 combinations, because there will be x3 also, 5 inputs. So instead of 16, you will have 32 combinations. So inside that, there will be 32 rows, and for every row, what should be ta, what should be tb, what should be y1, what should be y2, are computed and just stored in the memory. You don't have to do much work, just remap this. Yes, a new model is available. The state diagram changed, then state table will change. So you will talking about same two flip flops and two inputs done, but the state table changes because of change in the uh, working of the system. Then state table changes. Then what you have to do is only change the values stored in this memory, and that gives you a new machine made available. So with little efforts, any type of machine can be created, any type of machine can be modeled, modified. So, depending on what type of memory you are using, if you are using ROM, then only one type of machine is made available. If you are using PROM, then yes, this you can train once, and then this machine is available. If you are talking about EPROM, then yes, sometime you can work with this table. No, you want some other table, then erase this using ultraviolet exposure and then reprogram it. Then you have another machine available. If you are using EEPROM, then create one. Not happy with that, erase this electrically, create one more, and so that way. So with a single machine, single connectivity, this can now behave in many ways. So that's a advantage of working with programmable uh, thing, and called a memory. Done. So instead of this, if you look into a higher version, then this leads us to something called programmability. So that's what we'll be looking in our coming future, the programmable devices, processors, and all that. So we'll see that in our coming future. So till then, take care. See you. Bye.